and welcome to the Open Systems Media webcast, Qualification of Libraries Using Static Analysis and Requirements-Based Testing. This webcast is sponsored by LDRA and Solid Stands. My name is Rich Nass, and I will be your moderator for this webcast. I am also the Executive Vice President of Open Systems Media. I lead the embedded and IoT teams for embedded computing design. If you are not familiar with that property, I suggest you check it out. It is for anyone designing hardware, software, firmware, or anything in between for embedded systems. It's located at www.embeddedcomputing.com. It is filled with blogs, design articles, videos, podcasts, all kinds of stuff. So you might want to check it out. So on this webcast, you'll be hearing from Andrew Banks, a technical specialist from LDRA, and Dr. Marcel Beemster, the CTO of Solid Stands. First, Andrew has more than 30 years of experience in high-integrity embedded software development. He is the chairman of the MISRA Working Group and the BSI Software Testing Working Group, and is active in lots of other committees, including working on the latest revision of ISO 26262. Dr. Beemster is a compiler technology expert with a PhD in computer science from the University of Amsterdam. He also has more than 20 years of experience in the compiler space, and he co-founded Solid Stands in 2014. So this webinar is about safety critical software and all the ancillary things that have to be put in place to make sure that the software performs as you expect it to. That includes third-party libraries like those that get bundled with the compiler toolchain. We will discuss when and where to use a library, and we will go through a series of industry standards. And of course, we will discuss the tools and techniques that can be used to achieve success. Before I bring out the two speakers, let me go over some of the housekeeping stuff. The entire presentation will take about 40 or so minutes, and that'll leave us plenty of time to answer your questions, and we will answer as many as we have time for. You'll find on the console window, there's an area where you can ask your questions in real time. I encourage you to ask your questions as you think of them, rather than wait till we get to the Q&A period, because we tend to answer them in chronological order. And as I said, we'll answer as many as we have time for. If we don't have a chance to answer your question as part of the webcast, somebody from one of the two companies will get back to you after we're done with an answer. So everything you ask will get an answer, just may not be as part of the webcast, but hopefully we'll be able to get to it. If you have a question pertaining to the operation of the webcast, like if the slides don't advance right or the audio doesn't sound right, put that into the question box and one of our technical folks will get back to you with a solution. You'll see a line of buttons along the bottom. One of those buttons is a handouts button. If you mouse over it, you'll see what each button represents. If you click on that handouts button, you can download a copy of the slides that we're presenting today. This webcast will be available in an archive version when we're done in a few hours. So if you want to go back and review, you can forward it to a friend or a colleague. It'll be there for you. Okay, that's all from me. I would like to bring out Andrew Banks to start us off. Andrew, take it away.
Thanks very much, Rish, and good morning, good afternoon, everybody, and welcome to this webcast. Qualification of libraries using static analysis and requirement-based testing. In this first half, we'll give you a little introduction to library qualification. We'll touch on coverage, what we mean by that. We'll talk about achieving MISRA compliance, because it wouldn't be a webinar by me if I didn't mention MISRA. And then we'll hand over to Marcel, who'll do his presentation about how we go about qualification. So, first and foremost, library qualification. What do we mean and why do we do it? So, that big question, why qualify your software? Well, firstly, software qualification it's a mechanism primarily for reusing components not developed in accordance with the requisite standard. This applies whether you have developed with one standard and are trying to use it with another, or if you've developed it not in accordance with any particular safety critical standard. So from one example from ISO 26262, we have a way of reusing software is based on the qualification of that software component. So it's there front and center in the varying standards. What do we mean by that? So as I say, software qualification is, but what is it? The objective of the qualification is to provide evidence of their suitability. And again, I'm citing 26262 here, but each of the main functional safety standards has something equivalent in it. And so this is if you've developed your software not in accordance with 26262, what do I do? What's in scope of software qualification? Obviously, if you're developing code from scratch, you will develop it in accordance with the target standard that you're dealing with. But if you're not, well, it's any source code, models, pre-compiled code, or compiled and linked software. Now, by compiled and linked software, most of us call that a library. And specifically, it's general libraries, it can be other components, as I've mentioned, or it's software that's already in use. Now, one of the main requisites of qualification is achieving full structural coverage of your code. But what do I mean by that? Well, quite simply, structural coverage is a means of determining the completeness of your verification. How much of the code have you verified? Again, I'm citing 26262. It lists three particular mechanisms: statement coverage, branch coverage, and MCDC, or modified condition decision coverage. And just as an emphasis here, it's condition decision coverage that's modified. So it's MCDC, not MCDC, as a lot of people describe it. This little session is not meant to be an in-depth tutorial of structural coverage, but it's meant as an introduction. So, statement coverage. That means you've verified every statement. So, one test case in a linear piece of code will exercise all three statements, and you'll get 100% coverage. Excellent. But our code is rarely just a linear piece like this. So imagine a very simple if-then. One test case, if you have a true in your decision, will execute all the statements, and you'll get 100% statement coverage. But that doesn't actually tell you whether it's gone down the true or the false. So you do need to have a second condition. And this is where we describe branch coverage. Because you've only gone down the A, B1, C route, you have not verified the A, B2, C route. So branch coverage allows you or requires you to verify each and every branch in your code. This is very closely linked to decision coverage, where a decision is true-false, so you have to test each true-false, therefore you detect the decision and the branch, but we'll come back to that. So combining those two test cases, you've achieved 100% statement coverage and 100% branch coverage. Again, our code is usually more than just an if-then statement. Here's an if-then else. Our first test case, decision is true, so we go A, B1, C1 are the branches we're testing, but we cover those 3 of the 4 statements, so we're back to our 75% coverage, but we only get 60%, that's 3 of the 5 branches. Similarly, we do test case 2 with the false. We get another 75% because we're doing A, B2, C2, A, B2 and C statements, and your branches are A, B2 and C2, getting 60% coverage that way. Again, you combine them, you get 100% statement and branch coverage. By explanation of this, a decision is a Boolean, so it's true or false, but it's not a Boolean operator. So here we're checking for example, x is greater than 0 is a condition, y is less than 10 is a condition. Put them together and you generate a decision. So a decision is always that true or false, as I showed you before, and consists of one or more conditions. We can get into a lot more detail of these, and I mentioned modified condition decision coverage. That's probably worth an entire webinar in and of itself. And that is in particular is used at higher ASILs, if you're an automotive, DALS, design assurance levels in aerospace, or all the other various measures. So that's a background to your test coverage. My third introduction here is about MISRA compliance. Now, most of the functional safety standards now recommend or highly recommend the adoption of a subset, and many of them cite MISRA C or MISRA C++ if you're using C++. So what do we mean by being MISRA compliant? Now, right from the very first version of MISRA C in 1998, there's been guidance for compliance. And previously this has been included in the introduction of the book. The suggestion is, of course, a lot of people just ignore that and focus on the rules. After being approached by a national automotive standards body who wanted clearer guidance and more detailed guidance that they could issue to their industry, we've expanded the guidance. We've pulled it out as a separate document, and this was first published in 2016 and updated in 2020. And this gives clear guidance of what you should do if you wish to claim you are MISRA compliant. So what does it cover? Well, firstly, it's a freebie download, so you can have that. It's compatible with MISRA C 2012 or any future version. Amendment 2, which was published last year, now actually mandates this. It doesn't just recommend it. And the guidance will be compatible with the forthcoming MISRA C++. And actually, there's no reason why you can't apply it to earlier versions if you are still using those. We're defining what MISRA compliance is and how compliance should be demonstrated. You can't just say, yeah, I'm MISRA compliant. A new feature is it provides a mechanism for tailoring the MISRA guidelines. Importantly, and specifically relevant to this presentation, it has guidance of dealing with adopted code. We'll explain that. It clarifies and tightens a deviation process because sometimes deviations are required, and provides a mechanism for agreeing with the supply chain some pre-approved permits which help you with the deviation side. But compliance is not organizational, it's for a deliverable, and it's not really applicable to the software, but actually to the development lifecycle and the processes that you perform. Importantly, MISRA compliance does not mean no deviations. but actually no unresolved violations, and that means you can have deviations. Some QA managers tell you that you should have MISRA compliance with no deviations. Deviations are perfectly acceptable. So what is adopted code? And this links in a way to the opening slides about what the standards require for qualification. And adopted code is simply anything that's developed outside of the current project. It may or may not have been developed to comply with MISRA guidelines or any particular standard, and it's source code that is adopted unchanged. So here, typically it's the C standard library, device drivers from third parties, other libraries, auto-generated code, because once your tool has generated that code, you really do not want to be hand editing it, and also legacy code. Now, as far as MISRA is concerned, once you've started modifying a file, it ceases to be adopted code and all the rules apply. As I mentioned, sometimes a violation may be justified. This is particularly the case when you're dealing with some of the low-level software, where the rules are deliberately there to stop you doing things that 90% of the time you shouldn't be doing, but sometimes you may need to. Importantly, a deviation should not just document the existence of a violation. You're not just saying, my code violates rule 1. It should say why you're not going to fix it, what you're going to do about it in terms of extra testing or process, and should have an appropriate sign-off process. So you cannot approve your own deviations. Now, recently we added Guideline Recategorization plan, and this allows you to change the categorization of some of the rules. So what can you do, or can't you do, should I say? Firstly, you cannot change a mandatory rule downwards to required or advisory. You cannot change a required rule to advisory. But you can recategorize a required rule to mandatory, an advisory rule to required or mandatory, up issued. And new with this version is you can formally disapply an advisory rule with justification. In the past, some people have basically treated advisories as, oh, I'll ignore them if I don't wish to. So we've added guidance of how to deal with that. And how can you check compliance? And Marcel will go into this from a library in much more detail. Firstly, you can check the code manually. You can do manual code reviews. And you do need to do some manual review for the undecidable rules. But you really do not want to manually review 10,000 lines of code. Now, some compilers now include lightweight checkers of the MISRA rules. They tend to be fast because compilers need to perform that much more quickly, but they tend to only find a subset of the rules. They also tend to be optimistic, so you get a lot of false negatives. Why is it not advancing? There we are. You can use a heavier weight tool. These tend to be slower, much deeper analysis, and they check all the rules. Yes, they detect the easy stuff you found before, but they'll also find the much more harder to find. But they can be sometimes a little pessimistic, and you may get false positives. But my view is it's better to have a false positive that you can check than a false negative that you don't know about. So from a MISRA viewpoint, your compliance is when you've done what you're supposed to do. You cannot just say, I'm MISRA compliant. I'll say it again. You need evidence. So if you've recategorized rules, you've got that evidence. Your enforcement plan says how you're going to check the rules, and you have a compliance summary. And where applicable, you have deviation records. Now that may sound like a lot of work, but it's not really, because the first three typically are one spreadsheet. So what does this all mean when you're looking at libraries? Marcel will now give you that detail and how you qualify. Marcel, over to you.
Thank you, Andrew. So I'm going to focus a little bit more on the second part of the title, the requirements-based testing. And I want to go on a little bit hands-on with these requirements. So we have to wonder, where are these requirements anyway? Where do we find requirements? Now, my company, Solid Sense, we specialized in verification of the C implementation. So that's both the compiler and the library of the C language. We're very lucky that that there is this document. So here I've actually got a photograph of a book, the C standard. So at one time, the C standard was really published as a book. So today everything is online, but at one time it was a book. And you could buy it in the bookshop actually, and certainly order it on Amazon. Now this is a wonderful document, and it really helps our company, of course, to know what is the C standard. We're lucky to have it because so many languages don't have proper standards. They have some kind of description of what a language should do, but that's not a proper standard. And so for the languages that do have standards, we can really verify what they should do. Now, this is the place, this is the standard where we would find the requirements. Now, I'm going to look in particular at the C library and requirements for the C library. So let's take a look at an example here. So I'm going to dive into this function, the string copy, strncopy function, and its complete specification from the C standard is on this page. And we're going to look how, what does this look like in terms of requirements? Where are the requirements and how can we see those requirements here? Now, I'm going to make a little bit of a detour here because I'm going to talk a little bit about the Brexit. And this is an alternative Brexit negotiation. And at one day, you may remember the UK said to Europe, they said, well, we don't want to belong to Europe anymore. And then France and Germany in particular, very, very sad because, so where's the sad faces? They were very sad because they were going to miss the Queen of the UK, the monarch of the UK, because as you know, France and Germany, they don't have a monarchy anymore and they're still sad about that. So they started the negotiations with a strong requirement. They said to the UK, okay, you can leave, but we want to see your queen regularly. We want to have regular visits by your queen. Because, they like the queen and they would like to have some royalty over the floor every now and then. And then Theresa May, well, she was a bit surprised by this, of course, but she was quite smart. So she asked, well, you say you want to meet the queen regularly, but how often is that actually? So is that every 3 months that often? And then Angela Merkel and Macron, they said, no, of course not. No more than once a year. And then Theresa said, okay, we can do that. And this is what's going into the negotiations and into the agreement. And it says, the British monarch shall visit France and Germany not more than once a year. So what does the Queen do here? She reads this and she thinks, okay, I'm fine with that. And well, she looks at the papers and she sees Angela is gone now. And well, Macron she doesn't really like. So not more than once a year. She's not going to visit France and Germany very often, actually. So with this in mind, we can go back to the C standards, because the string copy function starts with this text over here. It starts with the text. What does it do? It starts with the string copy function copies not more than n characters. Now that's a very strange formulation of the requirement of this function. So it's not very clear. And if you read on, it doesn't actually say that this string copy function should be very eager about its copying. It doesn't have some obligation of activity. So if you read this literally, then you could say, well, okay, fine, this string copy function is fine by copying no characters at all, because that does not violate the literal text of this standard. So that's a little bit sloppy here, and so we have to be quite careful with extracting the requirements from our standard. Now there's more about this, so let's go to the next sentence here. It says, well, if copying takes place between objects that overlap, the behavior is undefined. Now what does that mean? It looks like if copying takes place, well, who does the copying? So that is the string copy function. So it appears as if the string copy function has to make sure that if the objects are overlapping, there's undefined behavior. And that's weird. That's not how you should read it. So you have to question really, and that's not just here, but all over the standard, whose requirement is this anyway? Who has the burden of fulfilling this requirement? Because the first requirement about the string copy implementation, copying characters, that is really something that the implementation should do. But now we're looking at something that is the responsibility of the programmer, because it doesn't say so here, but the control over whether functions are overlapping or objects are overlapping or not, that is the burden of the programmer. The programmer has to make sure that these objects don't overlap. So these undefined behaviors, and this is one that's explicitly mentioned here, and I can imagine two more on the next slide. These undefined behaviors in the function library, they should not really be defined or classified as undefined behaviors. They should really be preconditions of the functions. And somewhere else it can say, of course, if the precondition is not met, then you have undefined behavior. But it really means that it's the programmer that has to make sure that objects 1 and 2 don't overlap. And two others, the size of the first array, the target array, has to be at least n. If it's shorter than n, then again, there's undefined behavior. So that again is a precondition for calling the function. Now, this second one, the third one, they are more or less implied by the text in the standard, but they're absolutely not explicit. So that is something you have to be aware of as well with the standard. Now, going back to requirements, I've listed the requirements we have extracted from this about this string copy function. And the first two, we give them a unique label, so the requirement padding and the requirement return, they're actually at the bottom of the description. They're quite clear requirements. The second two, the red ones, they are a translation, our translation of this requirement that the string copy shall not copy more than n characters, because it's a tricky specification actually, because it deals with two cases. Either there's a string that is fitting in n characters, or the string, it doesn't even have to be a string, any piece of text that is n characters long. Those are really two different cases, and we have tried to make them explicit here with these two requirements. At the bottom two, they are not explicitly in the standard, and one reason is that the standard doesn't specify what a function should not do. So yeah, that's a bit superfluous, of course, that a function does not have this side effect, that side effect. You're not going to list that out, but as a programmer, we know that it's very easy to implement the string copy function and then write maybe not n characters in the target array, but also touch the n+1 character. So that is a requirement that we have made explicit with the requirement no more here in this fifth requirement that says, okay, you shall not write beyond the first n characters. And another requirement is that the source array should not be modified. Now that is also implicit, because if we go back to the original text here, then we see that the second argument has a const in front of it, and that means the const is a promise of the function that it doesn't change that. However, it is not enforced by the C standard. The const is not something that guarantees that a certain thing does not change. It's more like, okay, I promise to do that, but actually the language does not enforce that promise, so it can be violated. Okay, why do we want to do library qualification? Andrew already mentioned that, and at the bottom you see that there are all kinds of functional safety standards. I've listed 3 that we've worked with in the past: the industrial, automotive, and the rail standards. The automotive standard is very nice because it provides very clear processes of how you deal with things, and it's also recently updated, so that's also useful, especially in the software domain. But really you do that because library code, and especially the standard library code that you get with the compiler, which is a bit invisible to you because it's automatically there, but its code is going to be linked to your application. And if that application is safety critical, then an error in that library component may cause an error in your safety critical component, safety critical application. And that is something you want to prevent at all costs and at all risks. So it's not because you have to do it by the standard, but because you want to do it because you don't want to run the risk of hurting people. And the standards, okay, they're good because they provide guidance on how you actually do this. Now, in ISO 26262, there is this section about specifically for what I call third-party libraries, libraries that you have not developed yourself. So in Part 8, Section 12, there's this specification of how to qualify software components that were not developed according to the software development part of ISO 26262. Now, the primary requirement, and primary, I mean there the most intensive requirement that you have to meet is that you have to have and run a requirement-based test suite. And that is why I got to the C library test suite and the C library requirements, because if you want to do that, you need to know the requirements of the C library. And as we've seen, that's not so obvious from the language standard. So the library requirements can be derived from the ISO C library specification, but it's not a trivial activity. Now you have to deal with both the normal behavior of the functions and also behavior in the case of failure. Now the case of failure does not indicate the undefined behaviors. Undefined behaviors are beyond the control of an implementation of the library. If the programmer fails to meet the preconditions, then there's nothing that the library implementation can do about that. So that is not something you can verify or test. But the behavior in case of failure, in this case, means if you violate domain inputs that are defined also in the standard. So for example, if you take a square root of a negative number, that is a domain error, and there's error handling defined for the square root function, for many of the mathematical functions, that you can verify and that you can test. So that is defined behavior in case of failure, and that is what you can verify. And furthermore, ISO 26262 mentions if you want to qualify against ASIL-D, then you also have to take care of structural code coverage. So that means coverage analysis, and that goes beyond black box testing for structural code coverage. You really go into the code and you have to verify that all of your code coverage is done, as Andrew explained. Now, at Solid Sense, we developed a product called Supercard, and Supercard deals with the red bits of this overview. So this overview fits into the V model, which is at the heart of many functional safety standards. And we try to cover the C library requirements that we derived from the C standards. Now, you can, of course, move the ISO C standard into the V as well, but as we've seen, the requirements of the ISO C standards, they really need a translation into something explicit. And that's what we've done for this test suite for the C library. Now we also define, and now we get to the testing side, the right side of the V, we define test specifications that explain how those requirements are then tested by the tests, and we provide the tests themselves. Out of that, running the test, we get two reports. One is basically a traceability report with a link between all the requirements and the tests. And the second is we get an overview of our code coverage and our MCDC. I hope I pronounce it now right, Andrew. MCDC coverage comes out of that as well. And those reports are then integrated with your qualification report, of course. Now, a little bit more about how to create test specifications. Here I've listed for two of the requirements how we write those test specifications. And what we see is that in the test specifications, we mention the specific domains as well. So here for the first one, we say, okay, we call the function, but we include cases with the empty string, because that's a boundary case for strings. An empty string is a boundary value. And we measure for all the strings that are shorter than n. And we verify the null character that's at the end of the string, whether it's included in the copy or not. So everything that is required by this requirement is translated into how do we test that in our test specification. Finally, requirement traceability, that's important because this is then the report output, and that shows the link from at the top part, the definition in the language standard. So in the C90 standard, that is section 7.11.2.4, and that has a title, the string copy function. We have derived from that section, we have derived a requirement, and that requirement is listed below there. And linked to that requirement, we have our test specification, and that test specification is implemented by a specific test, and that test has a path into the test suite that is also provided there. And then we find the text of the test specification. And finally, at the bottom, we find a pass or fail status that is the result of the text. So this is the textual output of the test run. But we can also fit that into a spreadsheet like this, where every line, every row in the test suite, in the result here in this spreadsheet, describes everything from left to right. On the left side, the section involved. Second column is about the function that we're talking about, and all the way to the right side, we see whether the test has passed or not passed. So in total for the C90 standard, 99 standard, I think this spreadsheet is between 5,000 and 10,000 rows. I forgot to look up the exact number, but it's more than 5,000 rows in this requirement traceability suite for the C standard library. Deriving test cases, I already mentioned that a little bit. This is also from section 6 of the part 6 of the ISO 26262 standard. So where did the test come from? First of all, analysis of the requirements. Well, you need to have the requirements first then, of course. But then B and C, they are dealing with the domain of values that you're going to feed into your function. So you have to think of equivalence classes. If you think of our string copy function, you think of the empty string, strings that are between empty and n long, strings that are beyond n long. Those are, say, equivalence classes, and that means that within such an equivalence class, say all the strings between a length of 0 and n, you pick a number of relevant cases, and those you use for your testing. You don't have to test all the cases, but in every sort of subdomain that you define in this way, you pick a number of relevant cases. Second, analysis of boundary values. So that is typically, again, the empty string, the string that is n long, and well, for different functions, you have different definitions of boundary values. In case of mathematical functions, typically 0 is a boundary value, plus and minus infinity are boundary values, but occasionally it may also be pi that may be a boundary value, or 1 that is a boundary value for the particular function. And finally, also still very important, this is really based on experience, and it says here in the text guessing, but it's more experience. And those are the bottom two requirements that I mentioned for the string copy function, where we said, okay, we don't want the string copy function to touch beyond n characters in the target array. And it's not explicit in the standard, but it's a very easy programming mistake that you can make for the string copy function to write one character too many. So that is something you also have to think about, really. What are the difficult cases and what are the things that could go wrong with programming such a function? Okay, structural code coverage. Andrew has mentioned that extensively. It's required for ASLD. Well, if you have the opportunity, I would recommend also to use it for lower ASL levels. It helps with evaluating the completeness of your test cases. It does not guarantee completeness, but because code coverage might indicate sections of the code that you have not tested yet, and then you can think, how can I build a test for that still refers to a certain requirement. That's how you usually do that, but it doesn't guarantee that you have covered all of the cases in the code, because if the programmer forgot to include one of the cases in the implementation, that will not show up in missing code coverage. So it doesn't guarantee completeness, but it certainly helps to verify that all of the code that is there is tested. As I said, it's also relevant for other ASLs, and the MCDC testing can be part of your code coverage analysis. For MISRA checking, that depends where the library comes from and what you want to do with that library code. Because if you do MISRA checking and you are going to enforce MISRA guidelines, there will probably be changes to the code, most likely, because standard code that is not written according to MISRA guidelines is going to generate a lot of diagnostics for that code. So if you want to leave that code untouched and stay within part 8, section 12 of the ISO 262 standard, you cannot enforce MISRA code on the library. But if you think, okay, I do want to do that, then you have to take the library into your own hands and basically develop that under part 6 of the ISO 26262 standard. Okay, short summary of what's in Supercard. So basically what we try to provide in Supercard is everything you need for the standard library qualification of the C standards, so that it can be used for safety critical products. We provide a detailed breakdown of the ISO C library to implementation requirements. We verify, we break down the requirements into test specifications, and so we complete the bridge from the left side of the V model into the right side of the V model. We provide the steps between the specification and the tests themselves. And then finally, of course, we have the report generation and high code coverage there. So with that, I want to conclude. I think there are quite a lot of people watching, but please do ask your questions. We will, if we cannot answer all the questions, we will do that later offline. So feel free to hand in your questions, and we're happy to answer them. So back to Andrew now, or maybe Rich.
Yep, it is back to me, and I appreciate you handling some of those moderator duties, Marcel, making my job easier. Okay, so as I said in the beginning, ask your questions now. This is the time that you have with our experts. If we do not have a chance to answer your question as part of the webcast, one of these guys will get back to you when we're done. So, okay, here we go, guys. Andrew, since you were sitting so nicely without something to do, let me start with you. Where'd that question go? For third-party software, is it tested systematically against C library specifications, or could the test be only based on third-party software functional requirements?
Yes. The important level of verification is how it performs with your application. So first and foremost, you need to make sure that the code is performing to the requirement of your piece of code. Now, as Marcel has shown with the C library, there's lots of pitfalls with using the C standard and the standard C library. And in many ways, a good number of the MISRA rules are there to stop you doing things that the C standard actually permits you to do. So the heart of it is your application needs to meet your specification. But adopting or using third-party libraries brings complications where, because we don't really know what that library is actually doing. So the long answer boils down to you need to test, and but you also need to understand what the library is doing. Marcel, anything to add?
Very good.
No, that's okay, fine.
Okay. Let's see. Marcel, how do you get code coverage data of standard C libraries?
Yeah, in the optimal case, you would have, of course, the source code of the C standard library, because then you can use a code coverage analysis tool that operates at the source code. And that means that you have to translate and actually create that library with the compiler that you're using. So you're recreating the library. If you normally get an SDK with a library included in binary, in this case, if you want to look at the code coverage and you have the source code, then you would recreate that library from scratch by compiling it. And okay, that's not too difficult. If you have the make file, then usually the way to do that is arranged. If you don't have the source code, then it's going to be a lot harder, and yeah, almost beyond the scope of what ISO 262 requires, because then you would look into the binary code. You would go look at the assembly code. Now that's a lot harder. There are tools for that, and you can use simulators and emulators for that. But that would be another way of achieving code coverage analysis.
Okay. Andrew, should the user of the qualified component take external measures for the test cases of those failed during the test? Or how is a failed test case handled?
You need to remember that qualification is not absolute. So the qualification of a standalone component or a safety element out of context, as 26262 would tend to call it, only provides you a lot of evidence to help your application. So if you have a test case that fails, then you need to do something about it. Now, it may be that you can merely document that as a behavioral feature. You can record it as a characteristic, or even just log it as a bug, a known defect. But generally, you would want to make sure that your code is performing to its specification. And that's where, when I talked about adopted code, if you modify adopted code, it ceases to be adopted. Now, that can be tricky in the case of if, for example, you've adopted an open source library or something like that, then you have that decision to make of, do you fix it or do you just report it back to the original provider and hope they will fix it? So there's no simple answer, but really it will depend on the case by case. But normally I would expect you would need to fix it. Again, it depends on the criticality of the code.
Very good. Okay. Marcel, when is the appropriate time to port a library in-house and develop it internally?
Yeah, that depends a lot of course, yeah, that depends a lot. So if you get a library that has been qualified already, so from the vendor of the compiler and the library, then basically you can use that library in your application. But you have to be careful that you stick with the use case for which that library was qualified. So if the library was pre-qualified, it is always done for a specific particular use case. And that can vary from compiler settings or target configurations, or well, there can be a lot of parts in this configuration for which the qualification was done. When you then venture out of that use case that was pre-qualified, yeah, then the certificate, the pre-qualification certificate, does not hold anymore. And then if you still want to use that component, but you need to use it in a different way than the qualification was done for, yeah, then you need to take matters in your own hand and you have to look at it. And one of those things that's often overlooked is changing optimization options for the compiler, because that can have a lot of influence on the library code, because we think in our minds, okay, library code is all pre-compiled, it's in this binary, it sits there and we just link to it. But actually there's a lot of code in the C library and even more in the C++ library that is in the header files. There are many functions in the C standard that are defined as macros, not in the C standard, but the language definition allows macro implementation of certain functions. And that's quite often done to speed up the code. But that makes the code, that library code, susceptible to changes in the compiler settings. So it's compiled then in a different way. And so there you have to be quite careful that the use case still matches. With C++, it's, I would say, even worse, because all of the templates for C, and then there's many templates, in template classes in the C++ standard, they're all in the header file, so they're not pre-compiled, and they are, they can be changed by different compiler settings.
Very good. Okay, Andrew, is the qualified library called ASIL compliant, or is it still QM?
My answers are getting predictable. It depends. It depends on what level of qualification you've undertaken for your library. And even then, what you've actually done is you will have defined it as qualified as up to a particular ASIL, but it still only achieves the ASIL once you've tested it as part of your whole system. It seems to be a common misunderstanding that people can sort of claim, I have this device, it's ASIL D, or I have this piece of software that's ASIL C. No, it means you verified it up to that standalone, but until you test it or verify it in the full integrated system, only then are you able to demonstrate the level of ASIL compliance. So it will be higher than QM, because QM is effectively just your normal quality management process. So if you have verified it against all the requirements of a higher ASIL, then it is reasonable to say, to make that claim, but that doesn't guarantee that it will be compliant to that ASIL in the integrated system.
Okay. Here's one of my favorite topics, open source. Marcel, can you qualify open source libraries?
Yes, there's nothing in principle that stands between you and qualification of an open source library. There's nothing in the functional safety standards that say, okay, open source libraries cannot be qualified. You have to have a vendor that has responsibility for it. But of course, it's you still have to follow the processes, of course. But there is no vendor responsible for the library, so you cannot fall back on a vendor to provide you with a complete list of bugs, for example, a known list of errors in the code. You cannot fall back on well-defined software engineering methods that the vendor has used to create that library, because in the open source community there are, of course, standards for development, and there is quality control there, but this might not be very opaque, and it might not be written down and not very clear, and so you have very little control of the heritage of the code, and so you have to be maybe a little bit more careful about that code than you would be by code that is coming from a known source. But there's nothing in principle that prevents qualification of open source code.
Excellent. Okay, I think we got time for one more. Let's go back to Andrew. How do you handle auto-generated code that is not MISRA compliant or have MISRA violations?
This is a multi-layered answer, and perhaps it's a topic for a webinar for another day. Actually,
it isn't. It depends.
Well, no. There's three different answers here.
Okay.
First and foremost, there is the standard compliance process. So if you have a violation, it's how do you deal with that? So you may wish to just record it and process it as a deviation. Secondly, within the existing MISRA C book, there's Appendix E that actually gives you some guidance specifically on auto-generated code and removes some of the rules from MISRA because they're designed for human interaction. And thirdly, it could almost have been a planted question, this, but it wasn't. We're actually doing some work at the moment to produce a guideline reclassification plan for auto-generated code. And that is because we fully accept that there are many people generating auto-generated code that are having issues. So we've produced a set of permits to help people generate deviations, and it also reclassifies or recategorizes some of the rules again to help. So that's work that's in progress, and hopefully will be published soon enough. The permits have been published. So great question and nice one to finish.
Absolutely. So thank you very much. Speaking of which, there was a missing link in the presentation. If you click on the handouts button at the bottom, you'll see that link. And I was told if you had already clicked on that link, you might have to refresh your browser to see the link. That's also the same place that you'll find the slides. So we are out of time. I'd like to thank Andrew and Marcel for fantastic presentations and also for sticking around to handle your questions. I'd like to also thank LDRA and Solid Sands for sponsoring this event. And of course, we could never do any of these things without you, the engineer. A final reminder that all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. So thank you all for attending, and I hope you have a great day.